Welcome to this lecture on relative velocity in one-dimensional motion. In this video, we'll try to find out the concept of relative velocity associated with motion in one dimension. Means एक object एक straight line पर चलता है और relative velocity का क्या concept है. इसके साथ relative velocity के साथ साथ हम और दो terms की भी बात करेंगे, relative displacement and relative acceleration. Idea of relative motion is different than the concept of motion we have. Motion की जब हम definition की बात करते हैं, we say a body is said to be in state of motion if it changes its position with respect to set of surroundings. तो यहाँ जो set of surroundings हम term use करते हैं, let's call this set of surroundings as a frame of reference. Why we bring this reference into view? क्योंकि जब भी हम मोशन डिटरमाइन करते हैं किसी ऑब्जेक्ट का, हम किसी और चीज को देख के बताते हैं क्या ये अपनी पोजीशन बदल रहा है या नहीं बदल रहा है. तो ट्रेडिशनली अगर एक पॉइंट O में लेता हूँ और यहाँ पर एक ऑब्जेक्ट है A, जब ये A O को लेके अपनी पोजीशन को बदलता है, I say A is in motion. At some point of time, say T1, A was at x1. At another point of time, say T2, A traveled to a position. This position is a new position at time T2. So this is A at time T2. This was at time T1. This one. So this way we say कि every time we determine position of A, हम O को एक फिक्स्ड पॉइंट यूज करके उससे हम उसका सहारा लेके इसकी पोजीशन निकालते हैं. नाउ इट सो हैपन्स कि जो इंसान इस फिनोमिनन को देख रहा है, क्या वो O पर खड़ा है, क्या वो A पर है, या वो कहीं और खड़ा है, उसकी पोजीशन का भी एक सिग्निफिकेंस रहेगा. वी विल कॉल दैट पर्सन एज ऑब्जर्वर. और जो ये सारा फिनोमिनन है, we can call it as an event. So observer is something which can feel the change of position or somebody who can see this phenomenon. It so happens कि जो यूनिवर्स का स्ट्रक्चर है, इस यूनिवर्स के स्ट्रक्चर में जो पॉइंट O है, कोई ऐसा पॉइंट जो बिल्कुल रेस्ट में हो, वो अनअवेलेबल है. We have no absolute rest in this universe. That means there is no object in this universe which is at absolute rest. So there is no absolute frame of reference. Then what is there? There is anything moving with respect to something else. अगर दो पैसेंजर्स एक ही बस में बैठे हो और वो एक दूसरे को देख के ये कहे they are in the state of rest, perfect. लेकिन वो दोनों के दोनों they are in state of motion with respect to sun. They are in state of motion with respect to moon. In other words, the concept of relative motion arises as something which is a very common thing related to motion. So what is relative motion now? Relative motion अब ये कहा जा सकता है कि if I was observing a phenomenon like this, कि there is an object A which is in motion, जैसे इसकी मान लेते हैं velocity है VA और एक object B इसी line पर जिस पर A चल रहा है with velocity B. अगर मैं ये कहूं कि what is position of B with respect to A such that A in itself is in the state of motion, I have determined the relative velocity. So I have a definition for relative velocity. The definition says that if I determine the rate of change of position of B with respect to A such that A in itself is in the state of motion, then that rate of change of position of B with respect to A is called as relative velocity of B with respect to A. थोड़ी देर के बाद हम प्रूव कर सकते हैं एक बड़ा सिंपल रिलेशन. If I say the relative velocity of B with respect to A, which is again a vector quantity because velocity is a vector, it would be given by VB minus VA. The converse of this, if I say what is relative velocity of A with respect to B, it would be equal to VA minus VB. In its basic structure, ये equation एक vector equation है. ये equation एक vector equation है. That means you have to take into consideration the parallelogram law or triangle law to determine the difference of these two vectors or these two vectors. But in case of one-dimensional motion, we are saved of that. हमें उसकी जरूरत नहीं पड़ती है. Reason that we are dealing with two velocities along the same line. तो हम simply एक scalar algebra use कर सकते हैं इन दो vectors को subtract करने के लिए. Otherwise, there would have been a requirement of parallelogram law. However, जब यही चीज हम 2 dimensions में करते हैं या 3 dimensions में करते हैं, we would require necessarily the use of the vector methods or vector algebra for subtracting these two vectors. Right now, I go with a very simple situation now. The situation is कि assume there are two vehicles traveling or two buses traveling on the road. The road is straight. तो ये आपके पास एक vehicle है, ये दूसरा. Now these two vehicles are traveling along the same road with a constant velocity. इसकी जो velocity है, that velocity is 5 meter per second. और जो इसकी velocity है, that is 15 meter per second. So I have set up the values for VA and VB. अगर ये बस A है और ये बस B है, और I can as per that equation say कि velocity of B with respect to A. I am not now using arrow here because I already said कि वन डायमेंशन में हम इनको स्केलर्स की तरह ट्रीट कर सकते हैं. सो वेलोसिटी ऑफ बी विद रेस्पेक्ट टू ए विच इज इक्वल टू वी बी माइनस वी ए वुड बी इक्वल टू 15 माइनस 5 दैट इज 10 मीटर पर सेकंड. व्हाट इट मीन्स? इट मीन्स कि अगर हम इसको रेस्ट में ले आते हैं, सपोज आई पुट दिस वेलोसिटी इक्वल टू 0, देन दिस इज गोइंग टू सी दिस ऑब्जेक्ट एट a rate or it is moving with a rate of 15 meters towards A. लेकिन जब ये ऑब्जेक्ट भी मोशन में चला गया तो अगर इसने 1 सेकंड के टाइम में 15 मीटर का डिस्टेंस कवर किया, ये अपनी पोजीशन से 5 मीटर आगे भाग चुका है. It has already shifted by 5 meters. So what we will be seeing is कि जो अब इनका आपस का जो velocity है, that velocity we have to see is कि ये feel करेगा कि this object is approaching towards this object at the rate of 10 meters per second. The converse of this, अगर हम VAB लें, VAB, so VAB would be VA minus VB, which is equal to VA is 5 minus 15, that is minus 10 meter per second. तो साइन कन्वेंशन बड़ा सिंपल है. अगर रिजल्ट towards right to call it as positive, अगर result towards left है call it as negative. That means when you look at B from A, there is one velocity. When you look at A from B, or we look at B from A, there is same velocity, difference of direction. अगर एक forward है, एक backward. Now what would happen is कि अगर इस information को हम एक ग्राफ की शक्ल में represent करते हैं. So I have a graph which is plotted for a body which is in the state of a uniform motion. The graph looks like this, that if I take position along the y-axis, this position along y-axis, time along x-axis, I have a straight line like this which represents the graph. In this straight line, the slope of the straight line, जो इसकी slope है, that slope is representative of velocity. So I call it as VA. और मान लेते हैं कि जो point है, this point which indicates कि at t equal to 0, where was this object A? Say this object A was at x0A. So I am able to write an equation for this object A. XA is equal to x0A, which is the initial displacement plus velocity of A multiplied by t. तो अगर मैं initial displacement को 0 ले लेता हूँ, I simply have displacement is equal to velocity into time. Displacement is equal to velocity into time. That is true for uniform motion. Now, if I have another object traveling with the same velocity as A, that means this line is parallel to the previous line. These two lines are parallel. Call this as VB. So what's happening here? VA is equal to VB, and this distance is x0b. That means the position of body B at initial time t. What I get is I have another equation, xb is equal to x0b plus vb into t. If I think of these two bodies have the same velocity, that means va is equal to vb, I can show from here कि अगर इन दोनों को हम लें और I find out the difference of these two, I will be determining two things from here. One is relative velocity, other is relative displacement. So from here, if I find now the relative displacement of B, it will be given by xb minus xa. So let's subtract these two equations to obtain xb minus xa. So I have xb minus xa is equal to x0b minus x0a. तो मैं इस इक्वेशन में से इसको सब्ट्रैक्ट कर रहा हूँ, प्लस vb minus va into t. So it is vb into t minus va into t. vb into t minus va into t. t मैंने कॉमन निकाला है. अब इसको आप याद रखें, दिस इज रिलेटिव डिस्प्लेसमेंट, और इस तरह से हम डेरिवेटिव ऑफ डिस्प्लेसमेंट को वेलोसिटी मानते हैं. इन द सेम वे अब मैं डिफरेंशिएट करता हूँ इसको, डिफरेंशिएटिंग बोथ साइड्स ऑफ इक्वेशन विद रिस्पेक्ट टू टाइम. So I get d over dt of xb minus xa equal to, this is d over dt of xob minus xoa plus d over dt of vb minus va into t. Now this is what we call as relative velocity. This is relative velocity, or I will particularly call it as VBA, relative velocity of B with respect to A, because we started with relative displacement of B with respect to A would be equal to, देखिए ये जो quantity है, ये quantity असल में time independent है, because ये वो situation है कि before time started, at the time of starting time, ये दो positions बाद में बदलने वाली नहीं. So this whole quantity is a constant with respect to time, its derivative would be equal to 0. यहाँ पर जो ये डिफरेंस है, इस डिफरेंस को आप देखेंगे, इसको आप रख लें vb minus va, we have into derivative of t with respect to t, which will be equal to 1. So finally we have, therefore vba becomes equal to vb minus va. So this is our definition of relative velocity of b with respect to a. अगर आप चाहो आप vab भी निकाल सकते हो, and vab would be equal to VA minus VB. Now what would happen that if we have two bodies with different velocities? देखिए इस ग्राफ में जब हमने बात की that keeping the two velocities equal, relative velocity of the two bodies would be 0. एक बस आगे चल रही है with 10 meter per second, second bus is following again with 10 meter per second. There is a gap between them. That gap will continue to remain the same gap as the time passes by. In other words, there is going to be a relative velocity which is equal to 0, because VA is equal to VB as per this relation. तो ये तो बनी एक situation. Now let's say कि अगर दो velocities आपस में equal ना हो, so what would happen if the two velocities are unequal? A graph will be like this now. So this is the position time graph for two objects where the velocities are unequal. This is position versus time. The two velocity graphs or position time graphs will look like this. So this is one of the graphs, this is the second graph. In other words, ये जो slope है, ये slope इससे ज़्यादा है. So if I call this as VB, the slope of this line represents velocity of body B, the slope of this line represents velocity of body A. तो यहाँ पर एक खास बात होने वाली है कि these two graphs are going to intersect. Or at the point of intersection of these two, what do you determine? You determine that there is going to be some time instant at which both bodies are going to be at the same position. At some time instant, the bodies are going to be at the same position. And this point is, अगर आप real world situation में देखें, एक बस अगर जा रही है आगे with 5 मीटर पर सेकंड, उसके पीछे एक बस आ रही है with 10 मीटर पर सेकंड. At some point of time they will meet together, and that meeting together is called as overtaking. So this is point of overtake, point of overtake. So at that point of overtake, for a very small instant of time, both the bodies, they occupy same position, and that point of overtake will be the point of intersection of these two graphs. Later on in problem solving हम देखेंगे कि at what time will this point of overtake occur, ये कब occur करेगा. But in the meantime we have seen कि अगर दो objects की velocity equal हुई, suppose VB और VA, दो parallel lines हुई, they are going never to meet each other. In other words, they are never going to overtake each other. However, अगर velocity is different हुई, then there will be a point of overtake. There will be a point where they will be achieving the same position, and as such the value of point of overtake can be determined. So two equations we have seen. The relative velocity of A with respect to B is equal to VA minus VB. The relative velocity of B with respect to A is equal to VB minus VA. What happens कि अगर दो objects अब velocity VA और VB को लेके opposite direction में चलते हैं. Suppose this is A traveling towards right, this is B traveling towards left with velocity VB. Same equation, but there will be transformation. Transformation ये होगा कि suppose in this case I am trying to find out VAB. If I take the direction towards right as positive, direction towards left as negative, so it will be VA minus, should be VA minus VB, because ये object towards left चल रहा है. So this way this becomes VA plus VB. For example, एक बस जा रही है at 40 किलोमीटर पर आवर, opposite direction में एक बस आ रही है on the straight road at 60 किलोमीटर पर आवर. Then the relative velocity of A with respect to B will not be the difference, but it will be sum of the two velocities, VA plus VB. So in that sense, if you ever find ये हमारे पास एक object A है, it is object A traveling with velocity VA. This is object B traveling with velocity VB. So the relative velocity will be sum of the two velocities, not the difference. This is outcome of the vector nature of this equation. There are two opposite vectors and they are subtracted. Instead of getting subtracted, they will get added up. However, this case has to be seen slightly differently. अगर दो photons की बात हो, many a times a question is given like this कि what is the relative velocity of two photons traveling in opposite directions with velocity c each. In that case, we are not going to use this type of algebra. There is something called as relativistic addition of velocities. So in that situation, जब हम relativistic addition की बात करते हैं, the velocity which you will otherwise find VB minus VA will become VB minus VA divided by 1 plus VB into VA upon C square. Now this relativistic addition of velocities takes place when we have the velocities of two bodies very close to speed of light. So this is, now this relativistic addition will give a slightly different answer if we assume that VA and VB are very close to C. So in case of a photon, say this is a photon h nu traveling towards right with velocity c, there is another photon traveling towards left with velocity c. So what I have is, अगर मैं VB लेता हूँ, VB is equal to C, then VA is equal to minus C, because this is opposite. So this is B, this is A. I have, in this case, the answer will come out like this. So we have VB, that is C, minus C divided by 1 minus C into minus C divided by C square. तो ये हो जाएगा 2C divided by 1 plus C square, 1 plus C square by C square is 2C divided by 2, that is C. In other words, the relative velocity continues to be C even if they are moving in the opposite directions. In such a case, we don't use the result which we use for non-relativistic cases. This is a non-relativistic case. When velocity is very very small as compared to the value of c, तो ये जो term है, this term will nearly vanish. ये zero हो जाएगी because VA suppose आप उसको 10 और 10 की value देते हो, जबकि c की value है 3 into 10 raised power 8. You see कि this term will nearly vanish. So once this term vanishes, our answer comes out to be VB minus VA. But if the velocities are close to the value of c, then this term does not become ignorable. So we calculate it in this manner and answer comes out to be c. Remember that whenever two photons are crossing each other with velocity c, the answer comes out to be the c itself, because we are using a relativistic addition, not the normal addition of two velocities which are non-relativistic. Thank you.